am Bob Trembley. I am the outreach officer for the Warren Astronomical Society, and I am a volunteer NASA JPL Solar System Ambassador. This is a pretty cool program. We have a lot of the SSAs giving presentations during this event. It's a program where NASA recruits people who do a lot of astronomy outreach, and we get to sit in on teleconferences with mission specialists, engineers, scientists, get the latest scoop on NASA stuff, and then go spread the good word of NASA to the public by doing outreach events and things like this. But I'm going to be showing this package. I'm going to be giving a tour of the solar system. This package is SpaceEngine. It is available for free from spaceengine.org, or you can get it from Steam. I believe it's either 20 or 30 bucks. I can't remember. The Steam version has some downloadable content that all of the solar system objects that NASA has high resolution imagery of, that's what they use. So it's pretty cool looking. So I am going to, oh, isn't that nice? It's such a pretty app. So here's a solar system, taking a look kind of like almost top down view. And this is the solar system as it is right now. Now, one of the things I want to point out is the plane of the ecliptic. And plane of the ecliptic is most of the planets orbit in this flat plane, right like that. That is the plane of the ecliptic. So right now I'm centered on the sun, so let's go there. Go there faster. All right, so there's our sun, and zoom in a little bit here. If you have a really good solar telescope, you can get close to the sun and you'll see these things. These things are called granules, and there's millions of these on the surface of the sun. They're about the size of the state of Texas, and at time exposure, they look like boiling soup or like a lava lamp almost. And that's pretty much what they are, only they're plasma. So let's go right to the sun. Let's just go whoop right to the surface of the sun. The surface of the sun. There's no real surface of the sun. So zoom up a little bit. So there's your granules. So there is what the sun would look like if if it wasn't blindingly bright and you're right near the surface. So first planet out, let's go to Mercury, and you can do a search on just tons, absolute tons of stuff in here. So there is Mercury. Let's get rid of orbits, make it look pretty. All right, so there's Mercury, and you might note that it looks a lot like our moon. It's really cratered. Really cool thing about Mercury is that there are some craters at the North Pole that have not seen sunlight in a long time, and those have been detected, I believe, by Arecibo, which just took damage recently. But one of the cool things that you can do in Mercury, because Mercury orbits so close to the sun, and it's got an eccentric orbit, and its rotational period is such that it has kind of a bizarre thing happen. And rather than me try and find it, I have it saved. And that's one thing you can do. If you find something in SpaceEngine, you can save the location. So here we are on the surface of Mercury, and I am just going to time accelerate here and watch what the sun does. So here's a sunrise. It rises and it just hangs there. And then it goes back down. And then it rises again. So that is the double sunrise. Over on the other side, it does this double sunset. Or if you're in the middle of the planet, it'll just like do this weird thing overhead. So yeah, Mercury, that's a very odd thing that that Mercury does. So you can land on any of the planets and get really close. I said it's really beautiful. So let's go to Venus. Venus is bright in the sky, looks about like that right now. Can't see a whole lot under those clouds, so what I can do is I can just go over here and turn the clouds right off, and there is Magellan radar images of the surface of Venus. And I just read something on Twitter a couple weeks ago that Venus has a lot of active volcanoes, which is pretty interesting. So let's turn clouds back on and go to the home planet. I'm not going to spend a whole lot of time on Earth. You guys are all pretty much familiar with it. What I am going to do is go to that and show you light pollution. This is, I was rather surprised first time I saw this. This is actual recent light pollution maps. And I wanted to show you one thing. Oh, if I can steal Norb's thunder because he's not talking about light pollution ahead of me now here. So this is Minneapolis right here. And that is the fracking fields in North Dakota. And all those things out in the Gulf of Mexico are oil wells. So yeah, but so I hear sometimes when astronauts post pictures of cities at night, people say, "Oh, it's pretty." I'm like, "No, this is not pretty. This is human electromagnetic waste, and it's really not pretty, and it's easily fixed, and we should be doing something about that." But anyway, so let's go to our moon from here. Oh, one of the things that in Ken Burton was talking about size and distance is a lot of people think that the moon is like right about here. No, it's 30 Earth diameters away. Let's turn orbits back on. So there's the moon. It's really far away from the Earth. So let's go there. Oh, that's the back end. Okay, so there is the moon, and again, it's ridiculously high resolution. You can land right in that crater if you want. So that is just beautiful. But it has a whole bunch of saved locations. And let's see, Apollo 11, where is it? Featured, there we go, featured location. The Eagle has landed. The first one, go to. This is Apollo 11. Load, load, load. Okay, so, and of course I just drew away from it. So where is it? There it is, that bright spot. So that's where Apollo 11 landed. And I really, really wanted to show you how nice and flat it was around where the Apollo 11 landed. So now let's jump to a few years later and go to Apollo 15. You're making me look for it? Oh, fine. Oh, went through the moon. Clipping. Well, it's nighttime here. So let's fix that by doing a time acceleration and make it not nighttime. There we go. All right, so this is Apollo 15. That's where Apollo 15 landed. There's a big rill there and all these mountains. Get this thing angled here, right? There we go. So all these mountains, a little more dangerous than the Apollo 11 landing site. So again, you can fly like a drone over the moon, but we're going to go to Mars because you can fly like a drone over Mars too. Doink. All right, so let's go into Mars, and I don't see Valles Marineris, so let's, whoa. All right, let's choose Mars again. normal time. There we go. All right, now that's what I'm looking for. So I'm just going to land right in this giant canyon. So it doesn't really look like a canyon from here, does it? That's a canyon. So you can fly like a drone down this gigantic canyon. So yeah, Mars is pretty cool. Now, one of the things that I talked about in Warren Astronomical Society presentation years ago was the number of tidally locked moons in our solar system. Our moon is not the only thing in the solar system that keeps the same face toward the planets it's orbiting. There are a lot of moons in our solar system that do the same thing. So let's show you that. Normal time, normal speed. Don't want it to get away from me. So this is Phobos, and it is orbiting Mars, and you'll note it's keeping that same face toward Mars the entire time. Deimos does the same thing. A whole bunch of the moons in Jupiter and Saturn do the same thing. So that is really bizarre. Ceres is the largest asteroid in the asteroid belt. Well, it got reclassified as a dwarf planet in 2006. Where is the bright thing? Let's turn time on here. There are several bright patches. Oh, crap. There are several bright patches on Ceres, which could be cryovolcanic activity. That and that. But let's go to Jupiter. Next out. All right, there is Jupiter. And we've got the 4 Galilean moons orbiting. Again, you'll notice in that nice flat plane around Jupiter's equator. That's just like the planets do around the sun. But Jupiter has a lot more than 4 moons. So what does that look like? Well, this always shocks audiences when I turn this on. Let's go to settings and turn on dwarf moons. Boom, what a mess. So you'll note that close into Jupiter, there's not a whole lot, but you get out to a certain distance and you start getting a ton of moons. And some of these guys take years to orbit Jupiter. And Saturn, Uranus, and Neptune are just like this. Uranus and Neptune probably have a lot more, but we haven't sent orbiters out there yet. So Io is one of the most volcanic bodies in the solar system. It has an absolute ton of volcanoes all over it. And one thing I really wish that SpaceEngine had was like the jets coming out. I should suggest that to them. So let's go to Saturn. Last year at Astronomy at the Beach, I had a virtual reality headset. Well, let's turn those all off. I had a virtual reality headset, and I was showing people a virtual reality flyover of Saturn's rings that was made using this graphics. There's a professional version of SpaceEngine that allows you to create a camera path and flight path around the planet and stuff. So this is Saturn and its major moons. And again, you saw the mess of minor moons it had. There are some very interesting moons here. Let's go find Titan. There it is. Titan is, I love Titan. Titan is big. It's got a very thick atmosphere. Actually, it's like that atmosphere is like 500 miles thick. We landed on that when we sent the Cassini probe out there. And over the next several years, Cassini was orbiting. One of the things it found was these methane lakes, but it saw them from a reflection like that, right? Like that. But I can turn clouds off. Go land in these lakes. So there you go. There's Saturn and the methane lakes. Well, no atmosphere, but anyway. So yeah, there's methane lakes on Titan. Now, Saturn has a ton of moons, and it has some moons that are called shepherd moons. These shepherd moons orbit within the ring plane of Saturn, and this is Pan. This is one of them. And I need it out of the shadow of Saturn. Why are you in the shadow of Saturn so much? Oh, wait, what's my red? There we go. I'm not really sure why it's doing this. Okay, well, a pass on Pan, I guess. So anyway, Pan orbits in the ring plane of Saturn, as do several things, moons and other gaps. So my graphics got turned down. Huh. Weird. So next out is Uranus, or Uranus, which CGP Gray pronounces it in this one video. I like that pronunciation, Uranus. So this guy orbits like around 90 degrees. Its ring plane and it's the plane of its moons is crazy compared to the rest of the solar system. So as this thing orbits the sun, eventually this plane will be pointing directly toward the sun and directly away from the sun. So its north pole will be pointing toward the sun for a quarter of its orbit, and then it's I'm not even sure what it's one side of it will, and the south pole will be. So, but I really wish we'd send orbiters out to Uranus and Neptune. Neptune has a very large moon with some very odd orbital parameters. So again, here's the right-hand rule. All right, we got Proteus orbiting that way. So the right-hand rule orbits that way. Okay. So Proteus is orbiting prograde. Triton is not. Triton is orbiting retrograde, and it looks a whole lot like Pluto. It is most likely a captured Kuiper Belt object, and it would be really cool to send orbiters or landers out there. One of the things that Voyager saw, it imaged little plumes coming out of the surface of it of Triton and wisping off into the atmosphere at a certain height. So, but yeah, it's that and Pluto, very similar. Speaking of Pluto. Okay, so what you're seeing with that red line is that's the barycenter. Pluto has a very large moon, Charon, and they orbit around a common center of gravity, which happens to be above the surface of Pluto. So let's turn time on here, make it go a little faster. So Pluto wobbles around that center of gravity. Now, remember we talked about tidal locking and how the moon always faces the Earth. Well, Charon is tidally locked with Pluto. The same face of Charon always points toward Pluto. But Pluto is tidally locked. Where is Pluto? Pluto is tidally locked with Charon. So the same face of each of these bodies face the other body continually. So let's land on Pluto and see if where's Charon? Well, let's go find Charon. Get Charon on the horizon. There we go. Oops. Well, okay, I didn't want to go to Charon, but I guess I am. And of course, there it is. All right, so there's Pluto. So let's back up a little bit here. Get a nice spot. All right, so there's Pluto in the sky of Charon. So I'm going to turn on time here. And that's what that looks like. That is just crazy. Pluto just hangs in the same spot. And because the orbital plane of Pluto it's kind of like Uranus, it's very, very tilted. I'll show you that, turn on the other moons. So that's just Charon, that's the one moon. But again, Pluto has several different dwarf moons. There we go. So there's the ring plane of it, and notice it's highly tilted to the plane of the ecliptic. So there are a lot of other bodies in the solar system, and let's go out a ways here. Angle it down. One thing I haven't talked about are comets and stuff like that. So let's go just turn those on and have your jaw drop. So first of all, we're going to turn on asteroids. Boom. Yeah, there's a few of them. So get rid of that, go away. So what you're seeing here, that would be the inner asteroid belt between Mars and Jupiter. All the rest of these, which are stressing out my graphics system, are Kuiper belt objects, and some of them go way out. These are asteroidal bodies and probably some icy bodies, but they're not comets. Let's add the comets in. Well, actually, let's turn these guys off and turn the comets on, because with all of them on, it's a little bit overwhelming. So there's comets. These are all orbits of major comets. And what's interesting, I've been doing in my weekly post for the Vatican Observatory Foundation, a tour of nearby stars, starting with Alpha Centauri and just going out. And I've got out to about 15 light years. And from about 15 light years away, you can still see the farthest comets like that. So I'm going away from the sun here, and you'll notice some of the stars close by. I'll bet you that's Proxima, is it? No, that's not. Maybe that one? Yeah, anyway, so heading out from the solar system, I've pretty much covered everything I was doing in the solar system. So let's go through the rest of the galaxy, because some of the stuff you can do with SpaceEngine is just amazing when it comes to galaxies. So let's turn the comets off. Doink. All right, so there's our sun. There's our sun. So I'm just going to click off the sun and go a little bit of ways, and that's pretty much gone. So we're 300 some odd light years away, and you can't even see the sun in the sky, and there's just so many stars. And this is one of the cool things right here. I like about SpaceEngine is it gives you a real good feeling for the fact that you live in a sea of stars. Let's go there. So this is your old Windows screensaver, right? Well, your Windows screensaver didn't have dust clouds changing and nebula flying by you. So I'm heading in toward the center of the galaxy here. Things are starting to get real bright. Imagine that being your sky. There goes star cluster. Let's just stop a second here. So here I am, all these stars around here. And cool thing about SpaceEngine, I can just pick any one of them. Random. Doink, and hey, I lucked out. It's got planets. Now these are all hypothetical, right? Up to about 6,000 light years, if there is actual exoplanet data, it does represent the star and the exoplanet with whatever data we have. These are called procedurally generated. It just uses things are like this for this type of star, so that's what it creates. But let's go to that planet, see what it looks like. And oh, look at that! Oh, perfect. Oh, you saw I just randomly picked that. So here we go. This is a ringed planet, whole bunch. Ooh, look at that big moon. And so one of the cool things with SpaceEngine is you can really make some eye candy. Boy, that is a really boring moon. Usually they're all crater. I'll bet you that's a gaseous moon. These are all asteroidal moons, and this one is like a shepherd moon. Which that look like an asteroid. Blink. Wow, I don't know why it's doing that. Well, anyway, so my father-in-law was watching a program the other day, and they were talking about stars and galaxies and stuff, and he did not realize that our sun was in a sea of stars like this. And he figured it out when they showed him something like this. So there's our galaxy. Let's look for the sun. Okay, you are here. There's the stereotypical you are here, right there. There's our sun, center of the galaxy. Now our sun has several satellite galaxies. The large and small Magellanic Cloud right there from our standpoint. So they look like that, and you can see these other ones, these little guys orbiting the sun. But let's go to the large Magellanic Cloud here. This is in the southern skies, and I've never seen this with my own eyes. I really, really wish I could. So it is really, it's a satellite galaxy. It's irregular-ish because of its interaction with our Milky Way. But anybody care to guess what shape it is if I look at it from the side? Now, this is how SpaceEngine represents it. And I actually asked some astronomers at the Warren Astronomical Society, and they're like, "Yeah, maybe." So they're just from the other side. So I can't guarantee that's right, but that's how SpaceEngine's representing the large Magellanic Cloud. And again, I could pick any star in there and just go anywhere. After you get out, those are all galaxies. There's your Hubble Deep Field. And you can see me rotating around the Milky Way here. So there are some really cool things in the Milky Way. Let's go back to the sun. And let's go to some of the things that we see in our nighttime sky, like the Ring Nebula. Wow, what is going on with the colors there? Well, that's better. All right, so let's go to the Ring Nebula first of all. I think this might be the first or second thing I ever saw on my telescope. All right, so that's a pretty good representation. Let's just back off of it. It's pretty good representation of the Ring Nebula, as you'd see it in the time exposure. A recent Hubble image showed these additional rings around it. Well, you're seeing this, looking down a tube essentially. And what I mean is this: you look at it from the side. That's what you're seeing. So that's what we see from Earth. That's what's going on with the Ring Nebula. So all these objects are three-dimensional. So let's go to a cluster. Let's go to M13. Really, you can make me type that in like that? Go to, whoa, okay, that's, first let me back off a bit here. Okay, so there's M13, and it's really far above the plane of the galaxy there. So again, these are all 3D objects. You can rotate around them. Let's slow it down a bit here. There we go. So a lot of red stars in there. So I can just fly right through it. Again, I could pick any one of these stars and go to it. So it's really amazing to see how far away from the galaxy that is. That's really high up there. So there is an interesting object right in the center of our galaxy. Sagittarius A star. Doink. Yoink. So what you're seeing here, these are all of the stars orbiting the black hole in the center of our galaxy. And what's funny was the European Space Agency released a video recently that used this imagery. They turned the labels off like that, and then they did time acceleration, and this shows all the things orbiting the black hole. But you can't see the black hole from here. Let's slow it way down. You'll whip right by it. So there is the black hole, and it's got the nice jet and everything, right? The accretion disk. But it's kind of hard to see stuff. So let's just turn time off, doink, and make it less bright. So you can actually see the hole, just like you couldn't, because it's too bright. So there's the hole and the big plasma jet coming out. So one of the things it does do, gosh darn it, I can slow it down. There we go. Using a mouse and a keyboard. So here's the black hole. And the one thing it does do is that weird gravitational stuff, right? The bending of the accretion disk. So that's pretty cool. And if you want to get really scared, want to go black hole? Ah! Oh, you can't do that. So let's turn brightness back on. That is huge. Now, the interesting thing I found out with these, with the black hole is that, take a look, there's the plane of the galaxy, all right? It's not straight up and down. It's not shooting straight up and down out of the galaxy. It's angled toward the plane of the galaxy, and that is the way it is. So not sure why. That's interesting. So let's turn on time, but turn the orbits off. Slow it down a bit so you can see the dance of the stars. These are stars whipping around that thing. That is crazy. Yes. Go to. Oh, there's the Homunculus Nebula. And the Eta Carina Nebula. So again, I could animate this, make it all pretty with a camera path. But could you imagine having that in your nighttime sky if you're on like this a planet and that star right there? Oh, a binary. Oh, yes, let's show you some binaries. Let's go to Mizar and Alcor. This is something that we astronomers like to view. This is a star in Ursa Major. It's not actually a star, it's a multiple star system. Turn orbits on. So these things orbit on the order of what? Oh, only 182 days. That's not very much. So let's increase time. Okay, so these things are, again, they are orbiting around a common center of gravity. What's interesting to note is that they're always at the far point away from each other, and they're always at the close point. So you might think that's just two stars. It isn't. What it is two sets of double stars orbiting around their common center. So you've got two stars there, merge into one when you get far enough away, and two stars there. I really don't know why that's showing black like that. Probably because I'm sharing. So there's four stars. That is a quad star system. And interesting to note that many of the stars in the sky are part of a multiple star system. Solo stars are actually pretty rare. And we didn't find out about that until we had telescopes. Cygnus X1 is a radio source that they believe to be a black hole. Oh, where are you? There we go. So there is a black hole, and it's orbiting a companion star. Very big blue star. I have no idea why it's showing that black like that. Of course, I never did this before I started showing this. Nope. Weird. But anyway, so this black hole is most likely sucking matter off of that star. And there's the star. Because the black hole is so heavy, the star orbits around its barycenter, which is about right there. So that wobbles. So let's see, I'm watching chat. Does anybody have any place they'd like me to take them? Because I can go anywhere in the universe. Let's go to Andromeda. Come on. Andromeda Galaxy, go to. So there's Andromeda. As it appears in the in photographs, but again, SpaceEngine, I can do things like that. Andromeda has like 1 trillion stars compared to the Milky Way's 400 billion. So Andromeda is ginormous. And let's see, where's the Milky Way? You should be able to see it here. There it is, yeah. So it's heading right for the Milky Way. The Milky Way and Andromeda are going to merge in 7 billion-ish years. And probably no stars at all are going to collide because there's so much space between stars. But it will kick off a whole bunch of starbirth. Whoa. Let's see, I'll show you what I mean in the starbirth there. You take a look inside these spiral arms are going to be bright regions where new stars are being born, and there's just an absolute ton of them, like all of these regions here. Those would all be star birth regions, and when the two galaxies merge, gas is from the two galaxies will combine, and there's going to be an absolutely explosive star birth period, and you're going to have new stars. The sky's going to look very interesting, but 7 billion years, the sun's going to be at the end of its life cycle, so we'll have left the Earth by then, or not. Well, anyway. So one of the things I like doing with SpaceEngine is just flying through the galaxy. And this is every galaxy. Just a sea of stars. This just blows me away every time I do this. Screensaver or not. There's a discussion on the Ask the Astronomer panel about how far could an alien civilization detect our sun. There's our sun. Let's go out a bit. Yada, 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 until the stars start moving. So there's our sun gone about 300 light years. So the inverse square law, what that means is that the power of a radio signal or electromagnetic radiation decreases with the square of the distance. So the further you get away, the less by a lot this power of whatever radio signal. So I remember reading somewhere that after about several tens to several hundreds of light years, any radio signals from Earth would be attenuated so much that they would probably not be detectable. So, oh yeah, I wanted to show you this. Go back to Soul. Go to one of the things you can do with SpaceEngine is turn the constellations on. Let's go turn the constellations on. And let's go find Orion. Where are you? There's Gemini, Leo. Taurus. Oh, I'm upside down. No wonder. Ursa Major. Yeah, let's just go to Ursa Major. Okay, so there's Ursa Major. So let's not whip through the sun, whip around the sun. Thank you. So let's just start accelerating toward Ursa Major and watch the constellation lines. So yeah, those stars are spread all over the place. Man, it looks kind of crazy when you get far away from the Earth. So that's just a pretty funny thing you can do with it. So let's see, other interesting places in our solar system. Let's go back to Saturn. Actually, let's just go right to Enceladus. Okay, this is an icy moon of Saturn, and the Cassini probe that orbited Saturn for many, many years discovered something very interesting coming out of the bottom of it. So let's just flip it over. So coming out of the bottom of Enceladus, Cassini imaged jets of water, and it imaged them, and then they changed its flight path to fly near them, and nothing happened untoward. So they flew right through it and sampled it, and it's water vapor and stuff. But these jets are coming from subsurface oceans under the ice here, probably caused by hydrothermal activity. This thing is orbiting Saturn, and gravitational tidal forces are stretching that moon, and that's just enough to generate a lot of heat. So you could have under that ice something like the mid-ocean rifts in our oceans, where you've got life forms living in complete darkness and in incredibly high temperatures. Though those kind of conditions could be under the ice of many of the moons in the outer solar system of both Saturn and Jupiter. And they just found out Ceres could be like that. So, wow, that's pretty cool. So what time is it? 9:44. Okay, so let's take you to, Wolf 35. Why did I want to go to Wolf 359? Let's go to Wolf 359. Because it has an exoplanet. Wolf 359 is also the site of the giant Borg attack in Star Trek: The Next Generation. So this is a red dwarf star. Boy, I don't know why it's this. That is a red dwarf star. It actually has some actual exoplanets around it. 359c, a hot super Terra. Probably all cloudy. And what is the other one? Or that's the only one. So this is an actual exoplanet. If you hit the info screen, show you a real object discovery date, how it was discovered, and all the parameters. And then if these are actual bodies, they get all these parameters, orbital parameters and physical parameters from online catalogs, and they are constantly updating them because astronomy changes all the time. You can add your own. It's got a scripting language where you can add your own stars and add your own planets and stuff, and you can specify, goodness, terrain, atmosphere, clouds, rings, just a ton of different parameters. So you can create your own star systems if you want, or you can add star systems that are missing, update star systems, export planets. The Pro version has something that you can export like 4K images, and it it could take a long time to do the processing. So let's go to some other locations. One of the things you can do is if you like a place that you found, you can save it in this shows you where you've been, and these are locations. And there's a pretty cluster. I took a picture. Let's see if I saved it here. Pluto, no. Of course I didn't. Let's just go to one. So it's just a random one I picked. Now there's several saved ones that come with the application. You want to go there a little faster, please? Looks like I'm stressing out my graphics card. There we go. All right, so we got a moon. Oh, that's cool. Okay, so we got a moon orbiting a gas giant with the galaxy. Now imagine that is your nighttime sky. What would a race evolve as, or what would their views of space be if you had that as your nighttime sky? Now I believe I'm in the Large Magellanic Cloud, so let's see if I turn around here. Yep, that's the Large Magellanic Cloud. So there, the other side, you got the galaxy on one side, and and a few stars, smattering of stars. On the other side, you've got the entire plane of the Large Magellanic Cloud. So again, what would a civilization evolve as? How would their views of life be, or space be? Is the start screen? Ooh, look at that, biggest star known. I don't think I've ever been there. Oh yeah, I could take you to Betelgeuse. Let's see if it represents the way. I think that's a red giant star, and it represents red giant stars as very lumpy, like they actually would be. Come on. Oh, for crying out loud, why is it doing that black thing? I honestly, it's never done this before until I've given this presentation now. I have to go reinstall it or do my graphics setting. But let's go to Betelgeuse, because Betelgeuse has a couple procedurally generated planets around it, because there aren't actual planets around it that we've detected yet. Back. So there's Betelgeuse. Again, I have no idea why it's black, for crying out loud. So here's a planet orbiting Betelgeuse, and you can see it has a tail, because it is so close, its atmosphere is being blown off, and it has a bunch of crazy moons. But this thing is probably red hot. Its moons are probably red hot, 'cause that's Betelgeuse. I don't know why it's black. I'm sorry. So there you go. Oh yeah, so there's a nice molten moon. So let's go back to our solar system. God, I love the way it does that. Wow, where are my city lights? Hold on one second. I'm gonna hit my settings up. Style, sharper, brightness, yeah. Graphics. Pedal to the metal. Why are you doing this? I have made absolutely no changes to my settings in months. And of course, the day I'm presenting, it messes up. So let's turn asteroids back on. I'm an asteroid fanatic. Ooh. There we go. This is the asteroid of my wife, Constance. I had to create this one because it wasn't in the game. And again, it's black. Why is it doing this? I think I need to reboot SpaceEngine. So this is a real object, and that is its original name. But when you create something in SpaceEngine, you have to give it a shape. And I had no idea what its shape was, so I just told it to make it flat-ish, and it did that. So let's see. Oh, Polaris. That's a good one. This is the North Star, Polaris. How many of you knew it was a double star? And look at how that orbit goes. Let's angle this. There we go. So that is the North Star. I had no idea it was a double star until I fired it up here. And there's how they orbit around their common barrier center. I'm going to turn the orbit off so you can see that. Hello. Doink. So fun with gravity. So what is the orbital period on Polaris there? 100,000 years. So yeah. Actually, I believe, let's go see if it is still that way in here. There is a star, Albireo. It's a beautiful star, or double star, to look at in Cygnus. And it is incorrectly being represented as a double star. The Gaia mission determined that the two stars of Albireo are not actually gravitationally bound. So I think I'm going to have to write the author and tell him about that. So yeah, the Gaia missions changed a lot of the way we're looking at the way stars move around. So again, they thought for the longest time they were not sure whether it was an optical double, which it is, or a true gravitationally bound double, which it is not. So let's just fly through the galaxy and find a random something, because there's a lot of random somethings. Like there's a cluster there, way down below the ring plane. There's a couple clusters there. So that is your galaxy. That is your home. And I really wish we could see it other than inside like that. It would be nice if we could see it like that, but we can't. So anybody, I don't know why. I said I go to Beetlejuice. Rachel wanted Beetlejuice. Not really sure why it's not showing the stars as bright as it was. I said I'm gonna have to reinstall. But it said SpaceEngine, its user interface, it uses a lot of if you're a gamer at all, a mouse and keyboard gamer, you know, ASD, moving around and stuff. It's very similar to that. Clicking and dragging, very similar to many games. The only thing is changing the speed is you use the mouse scroll wheel. That's what I'm doing right there. And depending on if you're holding the wrong button down, you can whip around and get completely lost. So there is an application out there called Overview. It is a VR app, and it has several different modules, and one of them is that flyover of Saturn's rings, like I mentioned. It was made using SpaceEngine, and they're using the Pro version, and they've done I believe some post processing on it, but it's really cool. And I got it a couple years ago, my VR setup. The very first thing I ran was Overview because I knew about it, and I was blown away. And I showed it to Brother Guy and the Jesuits because that's where I got it. I was out at the VOS Faith and Astronomy conference or workshop, and I showed a couple people there. I showed several of the Jesuits, and then I came back home, showed it to a bunch of people in the Warren Astronomical Society, took it to a science fiction convention, showed David Gerald, the author of The Trouble with Tribbles, and it's just blown everybody away. It's just amazing, and I would highly recommend this. You try this in VR. It does have VR capability. And Overview itself is cheap. It's like $10. So if you have a VR headset, Overview. And one of the things Overview does is very much like I'm doing right now. It takes you up to a nebula, slows you down, flies you through it, and then what happened there? And then whips you back around, flies you out, and then takes you out, shows you the whole galaxy. And one of the really neat things in VR, you can pull your head through the galaxy like this, see the ring plane. You can do that with your eyeballs, and seeing that in 3D is just amazing. So I can't say enough good things about SpaceEngine. I said it's got a couple things that are kind of wonky with it, user interface wise. And again, I don't know why stars are being shown as black eclipse things in this one, but oh well. Again, never happened before. I'm broadcasting, right? So are there any questions at all? I'm looking at the YouTube chat. Holy mackerel. Double star with a planet? I'm not sure that planet would survive. Wow. But again, what a cool sky that would be, huh? Wow. All right, everyone. It is 10 o'clock, and I'm going to close this session down. Thank you for coming. We've got several people doing live broadcasting. We've got Brian Ottoman in Arizona. I believe they're still up. We've got Jeff Kopmanis. He is broadcasting from his driveway. And we've got a couple other people on. Thank you for viewing, and have a good night. See everybody later.